Now, looking into the characteristics, now, what is the most important group of customer that would want to like? Which group of people will generate the most revenue for us? Can you see that? Can you tell from this graph? Which group of customer would generate the most of our profit, contribute most of the profit and most of the revenue to the airline? Can you see that? Group 2, right? Why group 2 is generating more? Say louder. Can you hear him? Can you hear her? Yeah. Yeah, can you hear her? Yeah, okay. Okay, so the second group is the most important group, right? Because in the past 12 months, they fly a lot, right? And they accumulate a lot of flying mileage, right? So they are generating a lot of revenue and profit for us. Okay, so so is this group of people very senior? Not really, right? Not really. Yeah. Do they? And they actually generate a lot of so-called quality miles, right? So this is kind of like a business traveler, isn't it? Right? So for airline, this business traveler is very important, right? So now looking into this characteristic, you can actually guess. You can actually infer what type of customer is that. So so what is the what can we say about group 3? What can we say about group 3? Okay. I
Group 3 earns the most of bonus miles, so they probably spend the most outside of their traffic tickets with.
yeah. Most of they earn a lot of bonus mile, right? Okay, and they also have a very high balance, right? They have the highest balance actually. Okay, so they accumulate a lot of mileage from our alliance, but they do not use this mileage, and they not very often fly with us. Okay, so what can you do with this group of customer? What can we do with them? If you are a marketer, what can we do with them? They have a very high balance, right? So what can we do?
I wonder that if they fly fewer, or why they have more bonus than others.
Because they go to our airline hotel, they go to our airline car rental company a lot, right? It means that they travel a lot. They do not fly from us. They must. This is the customer that we want to acquire, right? We have their data. Okay, we get their data from our alliance, right? So and they have a lot of balance accumulated already, right? So can we kind of like design a program, try to give them some incentive, right? To use their mileage to fly from us, to fly with us, right? Isn't it? Right. So this is very useful, isn't it? this chart is very, very useful, right? By looking into this chart, you can tell the different behavior of different group of customer, and you can design a very specific campaign, right, to effectively try to improve your performance group by group, right? Okay, so this is the benefit of cluster analysis. Okay, if I'm just using like age group, like zip code, like gender, like this type of obvious existing customer profile, okay, people in the same zip code, they might behave very differently, right? But in this type of grouping, people in the same group, they behave similarly, right? They have the similar interest, they have the similar preference, so that you can design a specific program to address each of them, right? To get a better performance, right? That is the point of clustering. Got it? Okay. Now let's take another example for dimension reduction. Okay. Any question about clustering? No? Okay. Let's jump to, because of time, right? We don't have time for C. Let's jump to D. 7D. 7D is dimension reduction for perception map. What is a perception map? Maybe the easiest way is to like look into the data and look into the result. Okay. Now, let's read in the data first. This data is actually marketing research data. Okay, so in this side we have like 5 cafe chain store, right? Like Starbucks, Dandy, like 85°, like One Cafe, Ideal Cafe, right? So these are the brand. Okay, these are the brand, and these are the brand perception. What we mean by brand perception is that actually branding is just an image. It is just an imagination in customers' brand, right? What we mean by brand, it is not an objective physical thing, right? Brand is kind of like an imagination of customer, right? So how do you measure the brand image? You do marketing survey, right? So you actually go to the street and you do some questionnaire, right? And for each of the brand, you want you want your subject to score them, right? Score them by variety, by style, by product, by image, by branding, by awareness, by professional, by credibility. Okay? So you design a questionnaire, right? And you go to the street, right? And you ask them to score this 5 brand by their variety from 1 to 5. Okay? And you actually collect like maybe 500 questions now. Okay, So for each of this questionnaire, for each of the brand, they will have a score. Okay? For each of this brand attribute. Okay? I mean, for every questionnaire, for each of the brand, and for each of for each of the brand and for each of this branding attribute, there will be a score, right? So if this customer they like the brand image of Starbucks, then Starbucks will have a higher score, right? And then so after I like collect 500 or maybe 1,000 questionnaire, I do the average, right? For all of this scores, right? So this is actually the average variety score of this 5 brand. This is the average style score of this 5 brand. See that? Okay? So this is not a single question now. Okay? This is the average of a set of question now. Okay? So usually when you want to like understand your branding image, you will do this type of kind of like marketing research, right? To understand your brand image in compare with your competitors, right? Okay. Now, if I give you this data, what can you see? It's very very difficult to tell, right? The relationship between variable, the relationship between data point, and the relationship between data point and the variable, right? Okay. Let's see what dimension reduction can do. Okay. Let's see the result first. The result of dimension reduction would be like this. If I do a dimension reduction on this data, okay? If I do a dimension reduction on this data, actually I will generate a byproduct of this, okay? In this chart, it is actually a biplot, right? So they have the variables, right? These are the variables. 1, 2, 3, 4, 5, 6, 7, 8. There are 8 variables, okay? And there are 5 data points, okay? Every data point is a brand. Every variable is a brand attribute, okay? So with the dimension reduction technology, actually we can generate a product like this. Okay? So in this product is like very intuitive, right? So Starbucks has the highest image and awareness. Okay? And this ideal brand, they're scoring high in this four attribute. Okay? In compare with the others, right? And these 3 brands, they are kind of similar with each other, right? Is that okay? And for these 3 brands, the IB533, they are better in branding and variety, okay? But they do not perform as well. But Denti actually is higher in this dimension than this one, right? Okay? Because in this direction here, they are strong, and here they are weak, okay? So Denti is stronger in compare with IB533. Denti is stronger in this 4 dimension, but Denti is stronger in professional, right? Than in IB533, right? So IB533, they are strong in branding and variety, but in customers' perception, their profession their professional are actually very bad, right? Okay? So in this single chart, you can actually see three different things. Okay? First of all, you can see that the similarity of the data point, right? The point that are close to each other, they are similar. Okay? And for this one and this one, they are dissimilar with these three. Okay? The similarity of data point, that is the first thing. Okay? And the second thing you can see is actually the correlation between the variable. Do you know what is correlation? You know that, right? Anyone who do not know correlation? So what is correlation? Let's it's between two variables, right? The correlation of two variables. When these two variables, they are in the same direction, which means that these two variables are of high correlation, right? They are of high correlation. Which means that when a brand has a higher image, they tend to have a higher awareness. Okay? When a brand has a high branding perception, they tend to have a high variety perception. Okay? The angle between the smaller the angle between two variables, the higher correlation they are. Okay? You see that? Okay? And because this is a reduced dimension, right? Okay. Originally, if I want to like plot this data directly, it will map into an 8-dimensional space, right? But the 8-dimensional space is so difficult to imagine, right? See, so we try to like compress the data and make it easier to observe, okay? And we compress the data. We will keep the direction of each of this for each of this original variable, right? We will try to keep its direction in a way that the information loss, in a way that the most of the information can be retained in this graph, okay? We do not have too much time to discuss the dimension reducing algorithm and mathematics, okay? But you can think it this way, right? If you have a watermelon, right? If you have watermelon is 3-dimensional, right? Isn't it? 3-dimensional. And in the watermelon, they are sit, right? They are sit within this watermelon, right? So if I want to compress this 3-dimensional watermelon into a 2-dimensional plant, right? What would happen? It like if I compress it, right? And after I compress it, every point is still a point, isn't it? Right? But it would distort some of the information in that space, isn't it? In the completion process, in the dimension reduction process, it's going to kind of like, you will lose some information, distort some of the information, right? Okay. So mathematically, functionally, the dimensional reduction algorithm is trying to like avoid losing information while it reducing the dimension. It tries to keep the information as much as possible. Okay, so the information that it obtained, that it retained, in this case, is that in this dimension 1, it takes like 63.2% of the information. And in this dimension, it actually keep like 30% of the information. So as a total, in this two-dimensional space, it carry a total of 93.3% of all of this information. This is the original information, right? So when we visualize this data, right, we lost about like 6.7% of the information. Okay, although we lost some information, but it helped us to visualize this 8-dimensional space in the 2-dimensional space. Okay, it actually map every point. Okay, map every data point as well as every variable, right? Okay, in a way that we can see the similarity of data point, we can see the correlation amongst the variable, okay, and we also see the relationship between data point and variable. For example, this point has a high score in these 2 variables. This point has a high score in this 4 variable. See that? So in the same chart, you see 3 things. It's very important. The first thing is the similarity among the brand. Okay? Similarity among the data point. The second thing is the correlation among the brand attribute, the correlation among the variable, and most importantly, the relationship between brand and attribute, right? So with this chart, you can like do your strategic planning. It has a lot of strategic implication within this chart, isn't it? Right? But before doing that, let's see how we make this chart. Okay? Let's see how we make this chart. Traditionally, if you want to do this chart is called perceptual map. If you take the marketing course, you might already learn this terminology. Okay? This type of chart, I plot every brand as a point, and I plot every brand attribute as a direction, right? This chart has a name. It's called perception map. Okay, and usually when you learn perception map, the usual way is you need to do a lot of calculation. Okay. This is the traditional way to do the perceptual map. Okay, you do a lot of calculation and you do a lot of calculation and drawing in order to produce this map. Okay, this is the traditional way to do that. Okay, but today we don't do that anymore. Okay, today we are using this code chunk. This code chunk is good enough to generate this plot. Okay. So see, it starts with the data, right? Okay, we put the data, we call the data. This PCA is what we already learned, right? This is the function to do dimension reduction, isn't it? Right? And I say that when we do PCA with this cafe, we don't want its graph, because it would kind of plot one plot for data point, the other plot for variable, right? We don't want that. So we replace its graphing function, and we put the result into this by plot function, okay, to visualize the result of. I should say that this function is for the dimension reduction, right? It gives it the data, and then the result of the dimension reduction is visualized, right? Visualized by plot. By plot, it means that I plot data point and variable in the same plot, okay? Right. And you only need to specify some argument. You can generate a plot like this, okay? So here I repel, as I has explained, right? It just I just don't want to have this label overlay with each other, right? It's called repel. And I specify the color of variable. This is variable, right? Okay? So the color of variable is blue. And the color of IND is called individual, right? In this package, it called every data point individual. Okay? So the color of every individual, every data point is red. See that? And then I specify the label size, the point shape, the point size, and then you get it. So easy, right? So easy to do marketing research and compare your brand with your competitors, isn't it? Right? See, first of all, you do a marketing survey and you get data like this, right? Okay? And you put this data in a data frame, right? And then you kind of use this code chunk, right? You do a dimension reduction and you visualize the dimension reduction. Then you see this processional map, okay? And from here, you can tell a lot of things, right? First of all, I can see what is my closed competitor, right? Okay? And I can see that compare with my competitors, what is my advantage and what is my disadvantage, right? For example, like Denti, it has advantage in image, awareness, professional credibility, right? But it has the disadvantage for branding and variety in compare with 85C. See that? Right? So you know you can compare a lot of things with your competitor. Right? And the most important thing is this is the because you do the survey today, right? So this today's situation, right? You can actually you see this is your current position. You can plan for a direction that you want to go, right? See? If you are a brand manager, right? You can, with this plot, what is your strategy? You can try to go this way. You can try to go this way. You can try to go this way, right? See? So the important is knowing where you are is one thing, right? Knowing where you want to go is the other thing, right? But if you do not know the relative position of all of the competitor in the market, right? You don't know how to plan for your next step, isn't it? Right? So this is the usage of perceptional map. It lets you know where you are. And most importantly, you can compare your position with your competitor, right? So that you know that if you have a chance to improve, which is the direction that you want to improve. You get my point? Okay. So this is the business application of dimension reduction. See that? Any question? Yeah.
Professor, as you see in the whiteboard, does the distance between two arrows show anything related to correlation between two variables?
Distance?
Yeah.
No, what matters is not the distance. What matters is the angle between them.
Right.
Yeah.
I mean,
As I say, the smaller the angle, the higher the correlation. Right? It's quite intuitive, isn't it? Because if the angle are very small, right, then it means that when the image is high, the awareness is also high, right? And that is exactly the definition of correlation, isn't it? Right? Does it answer your question? Okay. Any more question? Now, sometimes when you do the dimension reduction, the sum of these two number might be like lower than like 50% sometimes. Okay, and that means that the dimension reduction lost a lot of information. Okay, in that case, you cannot trust this dimension reduction plot very well. Okay, but you don't really have too much thing to do with it, right? It really depends on your data. Really depends on your data. Okay. It depends on basically two things. The first thing is actually the number of data point. Okay. The reason that this positional map can carry like more than 90% of the original data. One of the reasons is that we only have 5 data points. So the data is by itself not very rich, isn't it? Right? So it's easier to retain the data. Right? If you have a lot of data points, then it's not easy to have a higher, to retain a lot of information, high percentage of information. Right? The second thing is the correlation between the variable. Okay? The reason that we can compress a high dimensional space into a low dimension, it really depends on the correlation between the original variables. Right? Correlation is actually the redundancy of data. Right? Can you see the point? Say if two variables have a very high correlation, right? Then I can use one variable to represent both of them, right? So if I have for example, if I have these two variables that they kind of like only have 1 degrees of angle between them, right? Which means that they are kind of like almost overlaid with each other, right? Which means that these two variables has a redundancy data, right? Because whatever carries in variable A is also carried in variable B, right? So in that case, when you do the dimension reduction, the information distortion can be avoided, right? Because you can squeeze out. When you reduce the data, you can squeeze out this redundant data, right? So whenever your data point is small, and whenever the correlation between the variable are high, you tend to see a higher number of information retained in this graph. Okay, it's the higher the better, but unfortunately, you don't really have a way to control it, right? It really depends on your data, right? Okay, so when this number are too low, right? For example, dimension 1 only have 10%, 20%. Dimension 2 only have 10%. You need to be careful because that graph actually has a large distortion. You need to be careful with that. Okay, when using as kind of a caveat when you are using dimension reduction. Okay. So today we learned two advanced algorithm, right? We learned two advanced algorithm in the R environment, which is Now, let's try to compare the algorithm we learned today with the visualization technique that we have learned previously. Okay, and previously, what we do, we have a data frame, right? And in ggplot, we try to use the existing variable, right? We map the existing variable. We use the existing variable to map the data point into a space, right? Usually for scatter plot, you can only have two numeric variables, isn't it? For scatter plot, you can have two numeric variable, right? For x and y's coordinate, and then you can use a categorical variable, a categorical column such as age group or area, right? You use it as color, as shape, as something else, isn't it? Right? So this is the easier way to visualize your data, right? We don't have some algorithm applied to the data yet, right? Okay? You simply use the existing column to do visualization. That is one way to do it, right? But the way that we learn today are kind of different, right? Okay? We actually do clustering analysis in this direction, right? We're using this variable, right? And now we can use a large number of variables. Usually when you are doing strategic planning, you're planning for something, right? So you are planning for promotion campaign. You are designing promotion campaign. There will be some variable relevant to that strategy, right? Sometimes you are doing product strategy. You have a set of variables related to product. When you are doing branding strategy, you have a set of variables that related to brand, right? When you are doing like, it's not only like marketing, also, for example, human resource, right? When you are doing the training strategy, right? So you have a training relevant variable, right? You have like promotion strategy, then you have a set of variable related to promotion. Usually you will have like more than two variable, right? Sometimes you have 5, sometimes you have 7, right? So using this variable, when you are doing product design and you use this product relevant variable to do the grouping, right? And that the benefit is because you are using this product relevant, right, variable to do the clustering, okay? So the group, within the group, the product are similar with each other, isn't it, right? If we are doing like customer promotion, right? So I have some customer preference strategy. I have some customer buying behavior variables with me, right? So if I cluster my customer with their buying behavior, the outcome I will have like several group of customer with similar buying behavior, with similar preference, similar interest, so that I can like design specifically incentive to attract this group of customer for better marketing performance, right? So that is the difference between the two ways. But in order to do that, you need to do some algorithm, some mathematics, okay? Fortunately, in art, all of this algorithm has already been encapsulated in functions, okay? And you can use whenever you want to do the clustering, you can use today's notebook as an example. Just put in your data, right? Then you can apply the clustering and dimension reduction type of things to your data, and you can do clustering. You can observe the characteristic of the different cluster. You can do dimension reduction, so you can actually see, okay. As I say that when you are doing brand strategy, then the variable are brand relevant variable, right? When you are doing product strategy, the variable are product relevant variable, isn't it? Right? So this dimension and clustering technique help you to map your subject into your strategic space, right? Into your high dimensional strategic space. Okay? So that you can, whatever strategy you want, as long as you have the relevant variable, you can apply what we learned today to help you do a better strategy and help you to communicate your strategy better, right? Now, strategy usually is not determined by someone in the company, okay? The company strategy usually is the result of a discussion within a board meeting, within a CEO's executive meeting, right? CEO's meeting. So within the meeting, what we can do, what we learn in data analytics, help to generate this chart, right? So it helps the decision maker to see the situation better and do a better strategic decision, right? And that is why we want to learn business analytics. Okay? That kind of conclude my talk today. Any question? Okay. So next week, we will spend some time for your presentations, right? Right? Every group, please prepare a 12-minute presentation. Okay? 12-minute presentation. Okay? And as I told you, we want to do these things. Sorry, I actually have some English slides. So but okay, so we want you to explore the data, right? Okay. And then use the insight that you find out from the data to do a strategy, basically marketing strategy, because what we have is really marketing data, right? Okay, so explore the data, find some insight, and try to use that insight to do some strategic suggestion for Tafang. Okay. So imagine that you are a marketing manager, right? And you want to present to your CEO, you want to present to the board the current situation, right? And based on the current situation, which of the group you want to focus on, right? What is your objective, right? For example, I want to focus on the age group of 28, from 20 to 25, and then I want to use this product, try to attract them, and then try to improve their frequency of buying by 20%, something like that. Okay? Use the data to draw some quantitative result, to display some quantitative insight, right? To display the insight visually, interactively, and do some suggestion. Okay? Of course, there's no standard answer. Just try your best. Okay? Question? Okay, if no question, that's all for today. Uh, I will see you next week. Okay? Maybe I'll see you in the TA times tomorrow. Okay? Or otherwise, I'll see you next week. So this week we do not have assignment, but you do need to. Wait a second. We don't have assignment, but you do need to finish and upload your midterm report, right? Okay, to the folder. Okay. No problem, right? Okay, I'll see you next week.